Matt, how do you feel?
I feel a bit tired.
Why?
I lay awake pretty much all last night because I was wondering where the sun had gone.
Right.
But you know what? Later on it dawned on me.
Oh dear.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Great, so we have to start off with an apology to our avid and now rapidly declining listeners.
Oh, please don't go
No,
away.
it was very funny, Matt.
Hey,
well done.
I just want to say thanks very much to everyone that did leave and subscribe to the to iTunes. That worked really well. Thank you very much.
Totally listened to us.
They totally listened to us.
I just want to. I can't believe it.
Yes,
Thanks, guys.
same again, please. Though let's just all keep doing it.
Same
Just
again.
keep doing
They're
it.
like,
So
what?
if
You
you
want
forgot,
more?
yeah, if you forgot, just do it. Hey, Jamie,
What?
it's podcast 37.
The Interplanetary Podcast.
Putting the ace back into space. And you might be thinking, gosh, they
caramba.
They did it pretty much in time there. And you know why? Because we're in the kitchen of dreams.
We're in the kitchen of destiny.
Is it destiny or dreams? I can't remember which one.
Dreams can come true.
In
Look at me,
Jamie's
Matt, I'm
kitchen.
with you. We've, as you can hear, guys, we've had a glass of wine.
Oh, no.
We've had some fish and chips. So we're going to be much more excitable.
Yeah, much more excitable.
Now, today's show, I'm really hoping that it's going to hurt your head as much as it's hurt mine.
We've
been crunching some numbers.
We've been crunching
Matt,
some
do you want to
numbers.
explain what kind of numbers we've been crunching?
We've been crunching some kind of big numbers. Some would say astronomical numbers.
Oh, good.
Quite literally. So today we thought it would be a really good idea to explain just how big space is.
And not just how big our solar system is, which will still hurt your head.
Yeah, this is gonna-
We've gone further out. haven't
Yeah,
we,
we're
Matt?
going to keep going out. So just so people have an idea of how hard it is to get to, say, our nearest star. In fact, now we've sat down and we've had a look at the numbers here. Getting to our nearest star just seems almost preposterous. It just seems preposterous.
Yeah. I mean, it's a wonder we can do anything.
Yeah, it's going to be monumental, the effort to get out. Well, as we'll see, it's monumental.
As we'll
just to get to Pluto was monumental. That's just amazing.
So where are we going to start from?
I think a really good place to start would be the centre of our solar system.
Oh, sweet.
So the solar system, as we know,
We're definitely the centre, right, Matt?
Yeah, it is. Currently,
It's all about us.
the centre of the observable universe is in Ladbroke Grove in London.
Yeah, it is.
That genuinely
Weird, isn't
is.
it?
No, genuinely is. Yeah.
Big time.
And the universe had to be this big so Jamie and I could exist.
Whoa.
Whoa, dude.
Deep.
That is deep. Shall I tell you what else is deep?
Oh, don't say
No.
this.
It's my poem.
Oh, okay, go on.
I dig, you dig, we dig, they dig, she digs, he digs. It's not a very good poem, but it's pretty deep.
What I'm worried about, Matt, is all of the new followers that we've got who really liked our stats are now just... Oh, what does that mean?
It
Is that
means-
another follower who's left because of your joke?
Yeah,
that's
that's
the
it.
alarm?
That's the unfollow alarm.
1,000 listeners gone.
Oh no. Well, that's only a blip, isn't it, in the interplanetary podcast world?
Talking about
So
blips,
shall we start our journey?
So we're
Shall
going
we
to start from
our
the sun.
journey in our spaceship of the mind?
Okay, here we go.
So we have flying out from the sun.
Buckle up.
Guess what we hit first? We're going to hit a small rocky planet. The planet named after the lead singer from Queen, Mercury.
Absolutely, yes.
And it's 36 million miles out from the sun. 36 million miles.
Doesn't sound like much, sure.
No, it
Put
doesn't
that
sound-
into perspective for us, Matt.
So if we've got a fighter jet that's travelling at 1,500 miles an hour, that means it could go from Land's End to John O'Groats, i.e. the length of Britain in half a day. Half an hour.
Half an hour.
Half an hour.
Yeah.
So it can do that in half an hour. However, to do from Sun to Mercury, it's going to take it 3 years.
Approximately 1,000 days.
Yeah.
About 3 years.
3 years.
Just to get from the Sun to Mercury.
Right.
Okay.
So almost twice as far out as Mercury.
Well, of course, we've got to Venus.
Venus. So that's another 3 years of travel.
Okay.
So now we've travelled 67 million miles.
We're totting up.
Oh, and a team of scientists, by the way, I've noticed, have discovered why there aren't as many volcanoes as there should be on Venus.
Go on.
There's a little. I don't know
This
why,
isn't
but
another dad joke, is it?
No. It's a news article, so
Okay.
that's one to look at. I
Okay.
did spot that in the news this week. So Venus
Yeah.
can't support life because of its runaway greenhouse effect, of course.
I'll tell you who can support life. Earth.
Earth. Let's play with it a while.
One of my favourite films.
Yeah, genius. So how long would it get to... So that is 93 million miles away from the sun. 93 million miles away from the sun.
Okay.
So that's 9 years of travelling. And it's not always 93 million
years
miles.
in the
but
fighter
that's its
jet.
average. That's his average, 93.
Okay.
It's obviously got a slightly elliptical orbit, so it goes either side of that a little bit. But that's 9 years of travelling in a fighter jet. Now, there's a unit that's called the astronomical unit, which is based on this distance, which is 1 AU equals this 93 million miles.
Why? What? Who made that up?
Well, there's quite a few astronomical measurements. As we'll see, all measurements start to get ridiculous. I mean, it's a bit ridiculous saying 93 million miles because
So
it
that's
doesn't
why
really
I guess
mean
someone's
anything.
like, look, this is silly. Let's
This is
just
silly.
call
Let's-
it
yeah.
1 AU.
Yeah. So you've got AU and you've got parsecs, which is to do with how far at 1 AU, 1 arc second will what distance that will be. So an arc second 1 AU away will transverse a parsec. So that's that distance.
Didn't the Millennium Falcon do the castle run in 12 parsecs or something?
It's something like that. But a
I bet-
parsec, yeah.
I bet there's probably a few geeks listening who can tell us.
1 parsec in miles is... Oh, that's a lot. We've got 1.9 times 10 to the power 13. So that's 19 with 12 zeros after it. That's a big number. That's a trillion. So, yeah, it's big. So in AU, a parsec is obviously a bit more manageable. So it's 206,000
I love you
AU.
say manageable, like, yeah, we could do that distance tomorrow.
So these are ridiculous numbers. So a parsec is pretty big. But AU, as we shall see, starts to become pretty pathetic even in terms of the solar system. It's mad.
Yes.
So after we've gone from Earth, our next neighbour is Mars.
Yes, it is.
Which is approximately 1.5 AU from the Sun.
Which is 141
million
miles. Okay, and in the fighter jet...
15 years to get there. 15 years. Now, after Mars, what planet do we have next?
Well, it's big dupes, isn't
The
it?
big Jupiter. Now, what's incredible, if you ignore the Sun, Jupiter is pretty much the entire mass of the solar system.
Yeah, it's ridiculous, isn't it?
It's like completely crazy.
It's a big fella.
It's
when,
big.
when we found them, when we saw those beautiful photos this week and last week
Oh, yeah.
of the storms
Yeah.
going on over the South Poles that are each as big as Earth.
Oh man, I tell you what. No, I tell you what's brilliant as well. They've just released a video clip of a flyover using those images. So they've
Really?
stitched them all together, and you get an actual sweeping over of Jupiter, and it's just
Sick.
incredible, and it almost makes you feel kind of a bit queasy because it's just the whole this spacecraft spinning over the top of Jupiter.
We're pretty small, aren't we?
We are pretty small, but this is incredible. So Juno is operating at 483 million miles away from the Sun. So, like, at some times, of course, Jupiter's the other side of the Sun. So it will be over 500 million miles away, and sometimes it's going to be slightly under 400 million miles away.
Correct.
But it's round about there. So if you're in the fighter jet, how long would it take you to get to Jupiter in a fighter jet?
37 years?
37 years-ish. So that's flying
Imagine-
full on.
Like, you know, when you like when we were kids, we used to drive down to Dorset, and when you got to Dorset, the stretch that you would have when you got out of the car.
Yeah,
I mean,
this,
imagine 37 years.
this fighter pilot's going to have a big old stretch when he gets to
It's
Jupiter.
a year younger than me. I mean, I know I don't look it, but
Yeah. So I could have flown to Jupiter in a fighter jet by now. That's really put my life in perspective.
God, it really has.
So then we've got Saturn. Now, Saturn, you think, okay, well, how far away is that? It's 888 million miles away. So that's almost
9.6 AU.
So almost 10 times further away than the Earth.
68 years in a fighter jet.
Yeah, it's just preposterous.
It's getting silly now.
So that is silly, isn't it?
Yeah, it's
I mean, this is
ridiculous.
like, that is a long time to get to Saturn. So Saturn's almost twice as far away. So Cassini is almost a billion, well, often he's a billion miles away, Jamie.
Oh, God.
No.
I can't fathom that.
No, it's just crazy, isn't
Well,
it?
we're going to have to continue.
We're
on
going to
this
have to
journey.
continue. So out to Uranus.
No, don't. You're better than that.
To Uranus.
Yeah.
We have 1.8 billion miles. So again, another over doubling of distance.
19 times further out.
So it's 19 times further out.
Oh, I'm going to ask the big one, Matt. How many years in a fighter jet?
Fighter jet, 137 years. Which is
Okay.
preposterous, isn't it?
Okay. How old's the oldest person ever lived?
Yeah, well, about 100,
140 or
no,
so?
124, something like that.
Really?
It's, yeah, some French woman. Yeah, you can't fly in a fighter jet, no matter how fit you are,
Oh, God.
to Uranus, right? It's just crazy. Neptune is 30 times further away than the Earth. 30 AU out. So they've already taken 200 years.
in a fighter jet.
Pluto,
Yeah, lovely Pluto.
40 times further out than the Earth. 40 times further out.
So it took New Horizon 8 years to get there.
New Horizon, the fastest man-made object.
Yeah.
So New Horizons goes 35,000 miles an hour. So that's now travelling through the Kuiper Belt. Now the Kuiper Belt starts. Kuiper Belt is a bit like the asteroid belt, except slightly further out. So we should have mentioned the asteroid belt. So the asteroid belt is in between Mars and Jupiter. So actually, even though it's very, very rocky, the rocks are so far sparsely separated that likelihoods of crashing into one are very, very remote.
Yeah.
So same with the Kuiper Belt as well. So the Kuiper Belt pretty much starts at Pluto, and the reason why Pluto isn't a planet was demoted, is because it hasn't cleared its orbit. So there's too many other things orbiting around that are too close to it, so they've decided it's not like a planet that's like pretty much cleared its orbit.
Pluto, clear your orbit.
Clear your orbit.
I'll do it in the morning, Mum.
Exactly, didn't have a strict enough mum. But plus, there's other things. There's other bodies in like make and things like that out in the Kuiper Belt that are about the same size as Pluto. So there are quite a few of these small planets, minor planets, whatever you want to call them, out in the Kuiper Belt. Now the Kuiper Belt, which still absolutely astounds me, stretches out to 50 times the Earth distance. So the Kuiper Belt itself is 10 Sun to Earth distances across. Now, quite recently, Voyager sort of made it out of what you would call that sort of part of space.
Yes.
And it hit a point called the heliopause, which is pressure of particles coming out of the sun and blasting their way across the solar system, hit the particles coming from the interstellar medium and cancel out-ish. So it's kind of like the end of the sun's influence in space. So that's kind of it. So Voyager managed to get to that point and beyond quite recently. We haven't even got to the Oort cloud. So the Oort cloud is theorised, so no one's actually seen it because it's so far away. But basically the theory is, and it's a pretty solid theory, is that there's lots of icy bodies that are out in this massive swarm of icy, like big icy things, like Halley's Comet and 67P that Philae landed on. I'm not even going to try and pronounce it. So, no, Churyevchenko.
Oh, he did.
Millions and millions and millions of these things out there, and that's known as the Oort cloud, right? And the Oort cloud is where a lot of the comets are coming from. So when another star goes quite near to the sun.
It sounds like something from Lord of the Rings, doesn't it?
It does, yeah. Going to the
We
Oort
must
cloud.
journey to the Oort cloud.
I guess how far out the Oort cloud stretches. Bearing in mind the Kuiper belt stops at 50 AU. That's a long way, right? Go.
200,000 AU.
Yeah, and that's not even a mistake. I actually thought that was a mistake. 200,000. So 50 AU to the end of the Kuiper belt.
Are you doing your calculations?
But 200,000, so like 1,000 to 4,000 times further out than the Kuiper belt.
Matt, have you got a tissue? I think my brain is leaking out of my ears.
So if you were sort of seeing the sun, you would kind of see that as part of its sphere of influence, because the Oort cloud is obviously in orbit around the sun. It's going to take Voyager 28,000 years to get to the edge of the Oort cloud. 28,000 years, and that's something travelling very, very fast.
35,000 miles an hour.
Yeah, it's not quite travelling that fast. It's travelling at 28,000 or something, because
Slow coach.
Yeah, slow coach. So, but a jet would take. So therefore, the jet that we're travelling in is going to take 1.5 million years to get there. So, which apparently is older than anyone. It's older than the human race itself. It's quite a lot older than the human.
Well,
Yeah.
the human race is on average about 200,000 years old.
Yeah,
as
so-
in
yeah.
Homo sapiens.
Yeah. So this is a long time ago. Dinosaurs. Dinosaur time.
Good Lord.
So the good news here is now we've been travelling for 1.5 million years in our jet. We've finally really reached interstellar space, out away from the Oort cloud. Now, to the nearest exoplanet, which is Proxima C,
Yes.
that is 4.3 light years. So if we want to go there, 4.3 light years. So
Yeah.
that's 275,000 astronomical units.
Okay, so this means that New Horizons would take about 83,000 years,
Yeah.
which means that the jet would take 2 million years to get there.
Yeah, so this is a jet that can go from Cornwall to Scotland in half an hour. Right? It can only do Earth to Proxima C in 2 million years.
This is unlimited fuel.
Unlimited
Never
fuel,
breaks down.
just blasting at its top speed, 1,500. The great thing about space, however, let's put this a little bit into space.
Please
When you get
calm
into
us down,
space,
Matt, 'cause this
no,
is
when you get
hurting.
into space, there's no atmosphere to drag. So any form of acceleration does actually accelerate you quite happily out into space and get you faster and faster and faster and faster and faster and faster. So if a jet had unlimited fuel, it would indeed get very, very fast, very, very quickly. You could get to Proxima C in something like the space shuttle in 100 years, as long as you had fuel tanks the size of the observable universe.
I love that.
Yeah, which is
That's a head
obviously
spin if ever there was
yeah.
one.
So flat out acceleration in space shuttle will get you there in a lifetime.
Also, weren't you in a band once called Atmosphere to Drag?
I wish I was.
Or was that a cabaret act I saw in Soho? I can't remember.
I think it's both. I was in the cabaret act you saw in Soho.
All right, so where are we up to?
So we're out now to Proxima C, but now we've got to Proxima C.
Well, you know where we may as well go to?
Go on. What's your favourite? What is your favourite nebula?
Well, you already know this, but it's, of course, the Horsehead Nebula.
The Horsehead Nebula,
Which is
in
how
Orion.
many light
Which is
years
in
away,
Orion,
Matt?
of course. It is 1,500 light years, and it's one of our nearest nebula. So this is one of the nearest nebulas that there is. M42, the Great Nebula in Orion, I think is slightly nearer. It's like 1.4, but it's all part of the same sort
All
of
right, so now
nebula system.
Okay, so now you're going to have to get your calculator out for the next sum.
So this is 1,500 light years away.
Which in miles is...
Which in miles is, what did we say? 8.8 quintillion.
Quintillion.
Or put another way, that's 8,800,000 billion.
Oh, God.
So 8.8. So it's basically 8 with a lot of noughts after 3, 6, 9, 12, 15, yeah. 8.8 with 15 knots. So, if we're in our jet engine...
Dare I ask the jet?
The jet, 670 million years.
Oh, and this is somewhere we can see in a telescope.
Oh yeah, so you can see it in a telescope. 670 million. Well, I've taken pictures of the Horsehead Nebula from my back garden. So it would have taken 1,500 years for the photon that left the Horsehead Nebula to travel across space, not hitting into anything until it whacked into the back of my camera and was recorded in my garden in Surbiton. So that's travelled 1,500 light years. It's just crazy. That, you've got to admit, is crazy.
Oh, that's insane.
It's so far away. 670 million years to get there in a jet. 8.8 quintillion miles.
All right, Matt. I'm going to hurt your head now because you hurt mine. What's your favourite galaxy?
The furthest away object you can see with the naked eye, the furthest away, you can look up into the night sky, and right now you can see, maybe a little bit later on in the year, you'll be able to see the Andromeda Nebula. And it was people like Hubble that kind of made people realise that, hang on a second, that it's not a nebula inside our galaxy.
That's no moon.
It's not inside our galaxy. So it was one of the very first things that people realised there was more to the universe than just our galaxy.
Just us.
And then
Surprise.
it was like, it's actually another galaxy like our own.
So how many light years away are we talking?
Andromeda Galaxy, being one of our nearest neighbours and will eventually crash into us, that's how near it is 2.5 million light years away. Not miles, light years. So that's 14 quintillion miles. So guess how many years in a fighter jet?
I don't guess at this point.
So that's 1 trillion years in a fighter jet. But of course, that's much, much longer than the age of the universe.
I actually feel a bit sick.
And do you know what's even funny about that? If you were in a fighter jet, you could never get to Andromeda. Do you know why?
Go on.
Because it's going too slow. So the expansion of the universe
is much
faster than the
we
jet.
Could ever do.
So as it's trying to get to Andromeda, Andromeda's getting further and further and further away. Although I just said it was going to crash into the Milky Way. So no, I think actually gravity is stronger than the expansion at this point. So it will actually.
Is it like
can
my
get
old
to Andromeda.
dog Ben that used to try and chase cars?
Yeah.
Yeah, he never got them. Bless him.
So can you imagine that? So that's one.
Oh God, that's just insane.
The furthest galaxy that we've seen so far is 13.4 billion light years away. Yeah?
13.4 billion light years away.
So that is that is 78 sextillion miles, or 7.8 with 21 zeros after it.
78 sextillion miles.
Yeah. So if we were to go there in our jet, it would take 6 quadrillion years to get there, which of course is 440 times the age of the universe. Now here's, how old did you say the universe was earlier on?
13.8 billion years.
So it's 13.8 billion years since the Big Bang. Now, however, here's a really funny one. So you'd think it'd be 38 billion years that you could see, but because of the expansion, this ever-expanding and faster expansion of space, the observable universe is actually 93 billion light years in radius. So in everywhere you look, the universe appears to be 93 billion light years in size. So that's 7 times bigger than what we just said then. So 7 times bigger than the 6 quadrillion years to get there. So it's huge. 7 times bigger. 93 billion light years. So it takes 93 billion years for light to travel from that. So, and that's to do with the expansion of the universe. So we'll never see it because it takes too long.
So when I said to you that I went to see the new Alien film at the cinema last week and I had so much junk food that I had to undo my belt to comfortably watch the film, is that kind of like what the universe is doing? It's just undoing a notch because it's just expanding. Like,
see, what's genius about this is that 13.4 billion years ago, a galaxy, say, was letting off some light.
yeah,
And then that light has been travelling for 13.4 billion years. But at the same time, space has been expanding out. And so the light kind of gets expanded out as well. And as it approaches, so when we see that light from 13.4 billion years ago, it's actually now 93 billion light years away.
yeah,
How crazy is that?
yeah. That's insane.
And what's happened is that the light wave itself has been stretched as well. So it's gone from white light and been stretched into red light. And that's what the red shift is all about. So the more red these galaxies are, the further the way they are in time.
That's the light that means we can kind of judge the Big Bang.
Yeah.
Whoa! Have we still got everyone, or is everyone feeling a bit queasy like me?
It is pretty amazing, isn't it? How big is space, Jamie?
It's really big.
It is massive, isn't it?
Do you know what hurts my head even more, Matt?
Yeah.
Is that we're talking about our universe,
Yeah,
of which if I had to make a bet, I'd say that we are living in a multiverse, and there are bubbles of universes all expanding and retracting.
Yeah.
So we're just talking about ours,
Yeah,
which is probably a dot in a load of bubbles.
Yeah, I really like that thing that Brian Cox said at that last week's science thing that he did, was the fact that obviously the inflation at the beginning of the universe might just be what's happening all the time everywhere.
Absolutely.
And that our universe is actually the slowing down of that expansion that creates the sort of visible universe that we have. Correct. Rather than this continual expansion.
Yeah, cool.
Inflation, I should say. Now we're just in expansion rather than inflation.
So the next time that you get worried about the election, or you dropped your keys down the drain, just remember these stats of miles and years and light years and red light.
And also remember, just when we send things like Mars Curiosity rover to Mars, that there's a robot on a planet that sometimes is like unimaginable distances away from us.
Oh, you can't. How can you imagine that distance?
And you think that it's incredible.
Yeah.
That thing is, we've managed to send something to a planet where the delay in getting the signal back is so significant, it has to do it all by itself and land on the planet.
And when we talk about the speed of cars and get really excited, that can go from 0 to 60 in... It's like, are you joking? Look at these stats.
Look at these stats. And then you think about Cassini and how he's been out there going around Saturn. Yeah. Saturn, which is 888 million miles away from the sun. And it's out there.
Doing its thing.
And then you've got New Horizons that's on its way to some tiny object in the Kuiper Belt that just being able to see it is a phenomenal feat, an achievement beyond achievements.
It's insane.
Yeah, we photographed Pluto. We photographed Pluto and Charon. We've sent things out that far.
Yeah, we have.
So we should really pat ourselves on the back that the universe is this big so that mankind existed, so that we knew the universe, so the universe knew itself.
When you say we should pat ourselves on the back, do you mean me and you? Because I think we definitely deserve that.
Oh, well, we're
bringing news to the people.
Yeah, I think we can hug it out afterwards. We can definitely hug this
Big
one out. Jamie.
Wow, that's amazing.
Yeah.
Don't give me another stat now.
I'm not going to give it. I don't think
I can handle it.
I'm not going to give you any more stats. I'm just going to tell you a little bit about some launches that are going to be happening soon.
Oh, go on then.
We're going to have a Dragon go up soon.
Awesome.
And that Dragon, what's going to be interesting about this Dragon, it's the first time they've reused a Dragon capsule.
Nice.
So it's going up on a Falcon 9, of course, and it's CRS 11 is going up, and it will be the CRS 8 capsule that's going up again. So they're reusing.
Wicked.
Not only are they going to reuse the launch vehicle, they're going to start reusing the capsules,
as well.
So that's pretty exciting, is it? So we got a pretty busy week as well. So on Thursday, the 1st of June, the Japanese might be taking off in an H-2A.
Nice.
Yep. And that's going to be launching a satellite constellation, the Michibiki 2 navigation satellite.
My favourite sat-nav.
Yeah, totally. Then Falcon 9, which we just talked about, the LC-39A, the famous shuttle and Apollo mission launch pad of destiny.
Oh, yes.
That is taking off from Florida, the Dragon resupply mission to the International Space Station. Ariane 5 is going off as well, and I think that's going to be a record weight again for Ariane 5, launching 2 satellites, a Viasat 2 and Eutelsat 172B. And then on Monday, to finish it all off, the Indians are going to be in action with a GSLV Mark III.
Good work, India.
So it looks like that's a pretty busy week on the old launch calendar.
On the old launch pad?
Well, yeah, so do you need to spot anything else in the old news this week, Jamie?
Well, I can't really think because you've thrown them stats at me. I just, honestly, I feel like I need to lie down.
Oh, there was one that caught my eye.
Go on.
Was a question from someone says, does NASA pay $18,000 for people to stay in bed and smoke weed for 70 days?
Right.
And the answer from NASA is no. NASA conducts bed rest studies, but it does not allow participants to smoke marijuana or even drink alcohol. So this was flagged up because a newspaper headline said NASA will pay £18,000 to stay in bed and smoke weed. Apparently, it's just not true.
No.
Classic false news.
Well, fake media.
Fake media.
It's everywhere.
Do you want to hear? Do you want to know what Thomas Pasquet listens to in space?
Go on.
He listens to.
Is this what he listens to? Are you just reading out really avant-garde Brian Eno albums?
He listens to Night Call by Kavinsky. Ever heard of that?
Yeah, I have.
Is it good?
It's great. It was the soundtrack to the film Drive.
Oh right, yeah.
You know?
That does ring a bell now. What about
It's a night call to tell
What about
me how I feel.
Disparate Youth by Santigold?
Also know it. Very good.
What about, I was going to say Veggie Farm, but that's not true. That he's just been harvesting lettuce from the Veggie Farm.
Veggie Farm sounds like the hippiest band.
Yeah, it's actually
in Cale
He's
University.
been listening to the song Banquet by Block Party.
Another sick back. This guy's got good taste.
Yeah, even though he's French.
great
I mean,
track.
normally that's.
Do you know why I like that song, Matt? Because it starts off with dueling Telecasters.
It is really good, actually. I do. Yeah, it is a good track. I once had breakfast with them.
Was it a banquet?
Yeah.
Good.
It wasn't. It was a breakfast in the John Henry's Cafe.
Oh,
Back in the day.
sausage, beans and chips.
Enter the Ninja by Die Antwoord.
Another great track by the controversial duo from South Africa.
Wow.
I believe it's pronounced D.
Pay No Mind by Madian and Passion Pit.
Oh, we love them.
I remember them.
Passion Pit. Well, not remember them. They're still about.
I know they're still about.
They're great.
We should say hi. Hi if you're
What's up,
listening.
Passion Pit?
What's that, Passion Pit? Yeah.
What's up?
That's it, Jamie. What do you think of Thomas Pasquet's taste in music?
he's
It's not too bad, is it?
He's got great taste in music,
Yeah,
but I think that it seems to me that he's listening to a lot of electronic music.
He does, doesn't he? He's
I'd
obviously
like to send him a playlist of my Nick Drake, maybe a bit of some classical music. Matt, what would you recommend? Something to calm him down in space.
Well, there's only one thing for me in classical music, and that's Bach.
That's all you need, don't it?
But he plays saxophone. Remember, his saxophone went up on one of those supply missions. So I wonder if he listens to Baker Street. Of course, we're only a few miles away from Baker Street here, if a mile away.
Do you reckon he annoys people with the Careless Whisper riff?
Oh yeah, or Baker Street riff.
Yeah.
Just the two combined.
Oh yes.
We should mention a news article by Eric Berger from Ars Technica. The inflatable space habitat that's passed its first hurdle.
Ooh.
So, it's been a year since the Bigelow BEAM has been up on the...
It has been.
Can you believe that?
It's gone quickly, hey?
Oh, that's gone. It has. The Bigelow expandable or Bigelow. I still don't know how to say it.
No. You don't?
Bigelow expandable activity module. I'm going to go with Bigelow from now on, rather than Bigelow. Doesn't sound right. Bigelow expandable activity module. So, with the installation of 2 radiation environment monitors, or REMs, not to be confused with the band,
Rapid eye movement.
or the dream state.
Yes.
Researchers at NASA have measured radiation levels and found the dose of cosmic rays to be comparable to those inside the rest of the station. So work will continue to try and understand whether the Bigelow module is any better than the station's aluminium shell. Bigelow module.
Radiation is so hot right now.
Not sure about that. So obviously a lot of this is going to go into the deep space gateway, because Bigelow might be the really ace.
The DSG.
The DSG. Be good if you make a massive inflatable space station that's in orbit round the moon.
And
I wish they'd just get on with it.
the good thing about that is that Musk will come back with something 20 times bigger.
No, but maybe Musk will go, I'll just leave it to
Just
Bigelow.
let him do it.
Because he's ahead of the game.
I'm drilling holes in LA.
So boring.
Oh, brilliant name.
It is quite good, isn't it?
Genius.
Oh, we should mention that John F. Kennedy would have had his 100th birthday the other day. I kind of have.
Yeah, you
John
have.
F. Kennedy had his 100th birthday the other day, or would have had his 100th birthday the other day.
Happy century.
Imagine if
JFK.
John F. Kennedy was still alive. God, he'd be a bit of a... Would he be as heroic as we still see him?
Who knows?
Just don't know, do you?
Just don't
He
know.
probably would have got caught up in some scandal and
Yeah.
lost his presidency that way.
Yeah.
It just wouldn't have been as cool.
But boy, was he good at the time.
Next week,
Yeah.
I'm going to have a co-host, a special co-host.
So don't worry, listeners. I'm not going anywhere. I'm just going on some trips.
Yeah. So hopefully they're going to I'm trying to get someone who starts with the same letters at least. Bear with Jamie. He's in Tuscany.
Yeah.
You may have heard that on the previous show.
Taking my mum to the Tuscan Hills, Somebody's got to do it. Goodbye, space hogs.
Remember the band Space Hog?
What's that?
Yeah. Bye, Space Hogs.
Bye.